a highly regarded methodology used in design, engineering, and business fields to promote business fields is known as design thinking. As shown here, design thinking consists of 7 interrelated phases. The first 3, understand, explore, and define, involve developing a deep understanding of the impact of the design. Included at the top of the list are the vast bodies of scientific concepts that govern the natural world. For example, the design of environmentally sustainable buildings requires an understanding of how the position of the sun will impact issues in relation to building orientation and energy conservation. As demonstrated in the technical videos, you will see how 123D design software can help anyone, regardless of their prior artistic or technical backgrounds, engage in the process of ideation. These same tools will enable you to take this, or other projects of your choice, through the remaining stages of design thinking that include prototyping, refinement, and presentation of final solution. Knowing how important knowledge of science is to the design thinking process, we now present the final overview of biomimicry. The term biomimicry is derived from the Greek bios, which means life, and mimesis, meaning to imitate. Biomimicry, then, is a thoughtful approach to examining the technology of nature as a source of inspiration for inventions, especially those that can improve the quality of life for people and our planet. A classic instance of biomimicry occurred more by chance than intention. After walking through the Alps, a Swiss engineer was struck by the way the tiny birds would stick to his clothes and to his dog's fur. Bonk, bonk. From this observation, and 10 years of development, came the quick and easy fastening system we now call Velcro. Another instance of nature-inspired innovation that first emerged through serendipity involved the development of unique wind turbine blades that improve aerodynamic performance and energy generation. The inspiration for the new design were the patterns of bumps on the fins of humpback whales. It was observed that these bumps, known as tubercles, enabled whales to swim in tight circles by diminishing the amount of turbulence produced as water passed over their fins. Wind tunnel tests on the prototype blades based on whale fins suggest a significant improvement in aerodynamic efficiency. Such breakthroughs can have huge impact on decreasing reliance on fossil fuels by greatly improving the output from wind farms such as these. The following examples of biomimicry occurred less by chance and more as an intentional process that marries science, technology, and design thinking. Addressing the challenge of designing improved demolition equipment, designers examine the ways in which a woodpecker uses its sharp, chisel-like beak to dig grubs out of trees and create nest holes. As illustrated here, the constant staccato hammering, or peaking action, of the bird was inspiration for the development of the machine used for demolition of structures, such as concrete walls. Staying with the theme of birds, the developers of the Shinkansen bullet train in Japan were confronted with a major problem involving the production of ear-deafening noises when air pressure changes occurred when the bullet train exited a tunnel. In resolving the problem, the chief engineer modeled the design of the train engine's front end after the beak of kingfishers. These are birds that are renowned for their ability to dive steeply from the air into water with minimal splashing. The result was a train that was quieter, used 15% less electricity, and traveled 10% faster. Leaves, with their amazing abilities that include providing natural shading, capturing sunlight, and forming it into stored energy, releasing oxygen, and serving as excellent collectors of water, make ideal biomimicry mentors. Here, the solution to creating a lightweight, efficient sunshade was inspired by the structure of a tree leaf. While looking to address the problem of limited water resources in Mexico, an award-winning student design team created an efficient, inexpensive, and elegant water collection system. It drew inspiration from the structure of bromeliad plant leaves for the funnel-shaped water collector, while the architecture of a spiderweb served as the inspiration for the lower support structure. The mysteries of life underwater have only begun to provide inspiration for innovation. Here, the ability of the shark to swiftly and efficiently move through water provides the inspiration for a two-person exploration submersible. By closely examining the biomechanics of human actions, such as gripping and moving an object, engineers and designers are making significant progress towards the goal of creating machines that can mimic the capabilities of humans. In the field of robotics, engineers and designers are closely studying the ways creatures, such as spiders, are able to travel across and climb a wide range of surfaces. For the following biomimicry design activity, you are provided with a concept model for a spider-type robot. With the support of the accompanying technical videos, you will be guided through the technical process of creating an attachment to the robot's legs that will enable it to traverse muddy terrain and swim through water. The biomimicry mentor for this design is a duck, and its webbed feet that provide greater surface area for travel over muddy terrain and serve as flippers for efficient swimming. After following the technical videos, we hope that you will engage in your own biomimicry design project, leveraging the capabilities of the 123D design to help you quickly communicate your creative ideas.